Looking at Earth from space, it's a wonder why it's not called Waterworld. Hello, and welcome to CU Science Update. I'm your host, Jalesa Moore. No matter where you live, the ocean's influence isn't far away. They cover over 70% of Earth. We're also the only planet in the solar system with abundant liquid water on the surface. Over a third of the total human population lives near oceans. As human populations grow, so does our impact on the oceans. The endless surf, roaring waves, and sheer vastness has an allure that goes back to our most ancient memories. On the surface, a place of recreation and means of transporting commerce. But deep below, the oceans still evoked a sense of mystery and awe. Oceans are the primary force behind Earth's weather and climate. They store much of the heat that reaches Earth. The rain that falls here in Boulder likely came from the ocean. Almost half of the oxygen we breathe comes from phytoplankton that live in the ocean, and the ocean absorbs some 50% of the carbon dioxide that we exhale and release into the atmosphere from the burning of fossil fuels. There's evidence that life originated in oceans. In fact, shortly after the formation of Earth, the deepest depths of the ancient oceans would have shielded early life from the heavy bombardment of asteroid impacts and radiation from the sun. They have been our protector and a force of destruction, yet there is worry that the oceans are more at risk from us. Rapid climate change caused by human activity could cause great harm to the ocean's ecosystems. Warming waters could cause irreparable harm to habitats, including the abundant corals. The bleaching of coral reefs has become a critical problem in reef ecosystems, and with global warming and warm water episodes, this bleaching is causing stress-induced corals to die at rapid rates. Researchers at the Cooperative Institute for Research in Environmental Science, or CIRES for short, have developed a new tool to forecast warm water episodes up to 3 months before they happen. This will help supplement the National Oceanic and Atmospheric Administration, or NOAA's, system of real-time satellite monitoring. There's evidence to suggest that Earth wasn't the only planet to have oceans. In fact, Mars had ancient oceans long before us, about 3.5 billion years ago to be exact. Yup, way back then, the red planet was also a blue planet because a third of its surface was covered by water. Scientists right here at CU identified surface features on Mars that were likely boundaries of ancient oceans. The study, conducted by researchers Gaetano D'Achille and Brian Heenick of the Department of Atmospheric and Space Physics, concluded that Mars probably had an Earth-like global hydrological cycle which included rain and snow, cloud formation and ice, and groundwater accumulation. And although Mars had 10 times less water than Earth, its ocean still covered 36% of the surface and was more than 1/4 of a mile deep. Future Mars missions, including the CU-led and NASA-funded MAVEN, will answer important questions and provide new insight into the history of water on Mars. Back here on Earth, we've had tall tales in ancient mythology of ocean travels and voyages to distant lands. In the Bible, Moses stretched his hand out over the Red Sea and God caused a strong wind to blow from the east. Thus the waters parted, allowing the Israelites to flee Egypt. And according to scientists here at Boulder, there could be a scientific explanation for that. At the National Center of Atmospheric Research, Carl Drews took his inspiration from the Bible's description of the wind parting the sea. He searched old maps and eventually found one that showed an ancient river merging with a coastal lagoon, forming a U shape. With wind blowing from the east, the 6-foot deep water would split through the bed and push back, leaving a dry passage for more than 2 miles. After running a computer simulation, he found that if a 63-mile-per-hour wind blew for 12 hours, it would push back the waters, exposing essentially a muddy bed that probably would have been very difficult to cross.
So the water has a bend to it like this. Suppose my hands are the water, and when the wind blows, the water shifts this way and splits at the point of the bend. So there's water on both sides. A bunch of refugees can come walking across or running across. When the wind stops, the water suddenly goes back together.
But imagine what it would have been like to have all that water crash back in. Water is an awesome force. It's also an efficient medium for transporting sound, which can make underwater a very noisy place. Raindrops smack on the surface, waves break, whales sing, and ship engines roar. When put all together, this underwater noise can sound like a big mess. CU Science Updates' Matthew Sewick looks at ways researchers can use the noise to keep an ear on ocean physics.
The soothing sounds of the ocean are so calming that we can be lulled into peaceful slumber. Above the ocean, air molecules transport the sound to our ears. But underneath,
under the surface of the ocean,
water molecules transport sound, often across vast distances, sometimes hundreds of miles. But instead of the tranquil waves up above, down below, the sound from waves, fish, whales, and submarines and shipping traffic can become one huge oceanic garble.
Yes, that's exactly what it is.
A team of researchers at CIRES and NOAA have been keeping their ears to the noise in the hopes of making less of it.
We should be able to produce much more accurate measurements.
Researchers like Oleg Godin want to turn all this ambient noise into an effective measuring stick for ocean physics.
We hope to be able to produce a new technique to monitor changes in the ocean using ambient noise produced by breaking waves, marine life itself, and also by shipping.
Measuring ocean acoustics allows Godin and his team to collect the latest data on subsurface temperatures and ocean currents that is so scarce right now. These numbers, calculated from the speed of sound, are difficult to find so deep in the water.
With acoustics you can measure what happens below the surface, throughout the depths of the ocean, as deep as you want.
The data will help scientists predict climate change, control pollutants, and more accurately forecast the motion and pattern of hurricanes.
For instance, oil spilled underwater, you know where it went, whether it went to the bottom or maybe it was carried by currents.
Now, using sound to understand the ocean is nothing new, but the jumble of noise proved troublesome for current methods, much like trying to pick out a single conversation in a noisy restaurant.
I think the amazing part is that we can use what was considered a hindrance to acoustic research, ambient noise. We can use it and retrieve information about the environment.
With up to 10 times better hearing than humans, mammals like dogs and dolphins can process a multitude of sounds with a wider range of frequencies. Inspired by this, Godin and his colleagues began listening to the ocean environment in a similar manner.
What's new in our technique, we try to do remote sensing without using powerful sound sources.
Remote sensing uses wireless recording devices to pick up sound, but current techniques collect data by first beaming loud sounds in the water to be collected, a technique that can be expensive and arguably harmful to marine life. The sound signals make it harder for whales to communicate long distances through song, and for dolphins and seals to effectively use their echolocation. Ambient noise fixes that using only existing ocean sounds. The method has gained wide support for its low cost and availability to expand the project worldwide.
We do not in any way pollute or influence the environment.
Godin hopes this method, once perfected, will reveal key information about the unknown depths of the deep seas.
Oceanology will become a data-rich science ready for the 21st century.
It will improve our ability to keep the ocean a clean and safe environment for marine life and humans alike.
And noise never stops. We should be able to produce very long-time series.
For CU Science Update, I'm Matt Sewick.
Now that researchers have figured out that ambient noise can reveal clues about ocean physics, they are working on perfecting the technique, making the method a standard tool for underwater acoustic observations. We can also learn other clues from mapping the sea floor. These maps were first used to monitor tsunamis and their impact, but now they are helping scientists keep an eye on the health of ecosystems. Researchers are starting to use the data to characterize fish habitats to reduce fish mortality from higher stream temperatures. Our awareness of these ecosystems attracted attention in the recent BP oil disaster in the Gulf of Mexico. 4.9 million gallons of oil leaked into the Gulf from an oil rig explosion. It was the worst oil spill disaster in history, affecting coastlines from Texas to Florida. Efforts were made to drop chemical dispersants in the water to break up the oil slick, but what effect did these chemicals really have? CU Science Update's David Starcer spoke with environmental engineer Karl Linden, who has been studying whether the dispersants have been helpful or hurtful.
Thanks, Jalesa. I'm here with Karl Linden of the University of Colorado at Boulder's Environmental Engineering Department. Thanks for joining me today, Karl.
Thank you.
And obviously the big project that you are working on right now, you got the grant for, is to study the oil dispersants that were used in the Gulf of Mexico after the BP oil spill. How did that all come about, and how did you guys end up getting this grant?
Yeah, so obviously everyone heard about the oil spill, and we were really interested in learning more about it, so I was listening to the news a lot. At one point I heard the EPA Administrator, Lisa Jackson, say that they're using a lot of dispersants. We don't know how they're affecting the environment. And we thought to ourselves, well, this is maybe a problem we should start to look at studying, because a lot of our expertise in my group, my research group, and that of my co-PI, Fernando Rosario, we work a lot in looking at how sunlight and UV light impacts chemicals in the environment. So we thought there's tons of dispersants being used in an ocean environment. It's kind of unprecedented. Yeah. The levels they've been using, apparently they dispersed over 2 million gallons of the dispersant over the time period of the spill. So we thought to ourselves, well, what's happening to this stuff? You know, we thought maybe we can use our expertise to look at it and study what the fate of these dispersants is. So we actually looked at some funding agencies. One of the agencies we often get money from for our research is the National Science Foundation, the NSF, here in the US. So they happen to have this program called the RAPID program, and they fund grants that are really important and essential to work on immediately, and that's why it's called the RAPID program. So we put in a proposal to the program manager in our division, which is the Civil and Environmental Engineering Division, and it's a quick turnaround thing. So we put it in as a 5-page proposal, and it was reviewed very quickly, and about a month later we heard that we got the award.
Obviously, there's a lot of people with personal attachments to what went on down there. I mean, people make their livelihoods on the ocean and everything down there. But just looking at it from a research perspective, for you as a scientist, how important was it for you to get this grant and to be able to go down and do some research?
Well, it's really exciting for us because it's obviously very timely, and we like to do things that are relevant to the public. And as far as this project goes, we decided to do a bunch of various outreach programs around it. So we're developing some modules for students in high schools to study oil dispersant mixtures and talk about chemistry, and talk about surfactants, and talk about properties of sunlight and how it decays different chemicals. So we're trying to use it as a teaching tool as well. And then we're also exploring with some social media outlets like Twitter and blogs and that kind of thing. So when we head down to the Gulf in a couple weeks, we're going to be sending back notes to classes here at CU that are studying environmental issues, and kind of keep them updated on what we're doing, and give them some information about the situation in the field. So it's a really exciting proposal and project to do.
Is it going to be kind of a back and forth thing where you guys will be going down there to do research, since you said it was primarily lab research that you guys do, or how's that going to work with you guys actually going down to the Gulf of Mexico?
Yeah, well, at this point we have water from the Gulf in our lab. We have a clean water site as a reference, and we have the chemical dispersant, and we're carrying out studies in our lab. And most of our studies are lab-based because we can do a lot of solar simulations in the laboratory. But we are going down to the Gulf, and we're going to visit the sites that we got the water from, meet some of the scientists who are working down there, understand what they're doing, seeing how we can collaborate a little bit better, and then just get some first-hand experience, which is essential. So we'll do that in a couple weeks, and we'll do it again toward the end of the project as well.
And are you able, you think, to get enough out of the actual lab studies than you would if it was actual field research, or does that make a big difference?
Yeah, actually we designed our project around lab studies because we can control the studies. We have a lot of high-end equipment in the lab, analytical chemistry equipment. equipment called liquid chromatography and mass spectrometer systems that can actually detect different constituents in the mixture. And more importantly, we want to detect when it starts to break down, what does it form into? Because we want to be able to figure that out, and then we can feed that information to the toxicologist, and they can say, this chemical looks like it's benign now because it broke down and we're not worried about it anymore. Or maybe it turns into something that says, uh-oh, it mixed with something in the ocean and now it formed some other weird chemical, and now that's more toxic. So I want to try to address those kinds of questions. That's really lab-based research. But that said, we want to get samples. We have samples from the field, and we will look at real samples in the field exposed to sunlight over time and see what we find from those as well.
The whole big picture, looking at the whole equation, is how we can do things that, as scientists, as human beings interacting with our environment, that don't harm the environment that we're trying to learn about and study. So I guess the question is, what is your take on that, and how important is it to, study everything that needs to be, I guess, discovered without, harming the environment?
Yeah, it's really exciting to be here at University of Colorado because there's a lot of great research going on. And actually, another professor in our department, Mark Hernandez, also got another rapid response grant to study looking at the exposure of the workers to the oil vapors and other things that they're doing and the hazards that they're getting. So that's another interesting aspect of things. But it's really exciting to be around all kinds of research, and certainly research that can directly impact ecological health, public health, and work on a timely type of topic like that we're working on, the oil spill, which is in everyone's mind still. It's really exciting for us.
Thanks, David. In fall of 2010, Professor Linden and his associates will return to the Gulf of Mexico. We will have more for you on their findings in future episodes. Oceans are a part of the human experience. The calming waves soothe the spirit and are home to plant and wildlife that are essential to our circular ecosystem. That's all the time we have. Thanks for joining us here at CU Science Update. Be sure to check out our other podcasts on iTunes.